All right, so today we're going to talk about law of sines. And later this week we'll talk about law of cosines. You should have had this in Algebra 3-4, but you won't have had probably all of it. You will have had the easier one. So let's go through the easy one first. And then, law of sines generally is easier than law of cosines. The issue comes into play with law of sines when you have a triangle in SSA format, which is a bad word spelled backwards. You remember that from geometry? You can't have ASS or SSA because it's bad word spelled backwards or forwards, and you couldn't prove that you had congruent or similar triangles that way, right? But with law of sines, it's different. We're not trying to prove the triangle is congruent. We're trying to find all of the interior angles and all of the side lengths. And so we can use what's called a law of sines in specific situations to find those missing values. So there's 6 parts to a triangle: the 3 interior angles and the 3 side lengths. You definitely want a highlighter. All right, so here I have listed for you the 2 formulas that are used for law of sines. You either put little a means the side length that's across from angle A. Capital A's refer to angle measures. So if you see a capital A, they're referring to the angle A itself. Little a, they're referring to the side opposite angle A. So they're named A and B and C for a specific purpose. Now there's 2 different formulas that you could use. Notice that they're reciprocals of each other, right? It doesn't matter whether you take the side length over the sine of that angle that's opposite that side, or if you put the sine of the angle over the side that's opposite that angle. It doesn't matter which way you do, as long as you remain consistent. You can't have this on one side and that on the other side. You're only going to use 2 out of the 3 ratios to set up one proportion. So you're not going to have all 3 of these, right? So you'll see that you might have this little a, and you'll have both of these angles, so you'll set up this proportion right here. Or if you only know angle C and angle A, and you know side C, you'll use those 2 ratios there. It depends on what you have. And it doesn't matter to me which one you memorize. It doesn't matter, but you do have to memorize those. I won't give them to you. All right, so then...
That's on the yellow sheet.
Yes. It's on the back. So now we're hitting the back of that goldenrod sheet that I gave you. Oblique triangles are triangles with no right angle. So that's what an oblique triangle is. A triangle with no right angle. So it could be an acute triangle, like this one is, or it can be an obtuse triangle like that one is. There are 2 situations where you might use law of sines. Situation 1, 2 angles and any side. 2 angles on any side. So that would be a situation where you have AAS or ASA. The side can be included in between the 2 angles, or it doesn't have to be. So this one is the side where the side's not included. This is where the side is included. Doesn't matter which. Or, situation 2, you could have 2 sides, and you must have the angle opposite one of the sides that you have. So you have 2 sides. You must have the angle opposite. So in other words, you cannot have SAS, because SAS is the included angle. It must be SSA, or you could think of it as ASS. This is the one that's the toughest, is ASS. This is called, well, you'll see. We'll spend quite a bit of time on ASS. So this is the one you probably did not do last year, was number 2. All right, so let's look at number 1. So this is a situation where you're given 2 angles on one side. So it's AAS. So we're looking at option number 1. Now note that they give you angle C, angle B, and side B. So you have 2 angles and you have the side opposite angle B. Perfect. Your job is to find all the remaining angles and sides. So first of all, I would suggest you start to envision what your triangle looks like. I might try to draw it. Now this one's in obtuse triangle, right? So draw it as best as you can. So I know I have one obtuse angle. So I'm going to name this A, B, and then the C is my obtuse angle, C. They have given me this is 102.3 degrees for angle C. Angle B is 28.7 degrees. And side B is opposite angle B. So I know that side B is 27.4 units. All I have to do is find angle A, side A, and side C. What do you suggest I do first? Why? Yeah. It's really nice when they give you 2 angles because it's very easy to find the third angle. So the measure of angle A is equal to 180 degrees minus the sum of what you've been given, 102.3 plus 28.7. And so the measure of angle A is equal to, you can use your handy dandy calculator. You get how many? 49 degrees. So you need to box out that answer because that's one of the 3 that's missing. So I'm going to put in my picture 49 degrees because it helps me to visualize it so that I can set up my ratios. So then you need to make a choice. Do I want to find side A, which would be right here? Side A is across from angle A. Or do I want to find side C, which is right here across from angle C? It doesn't matter, you choose. Which would you like to do? We'll go with A. Why is A better? Does it really matter? Yeah, it doesn't matter. So since I have A, I'm going to use A over sine of A equals, what full side and angle do I have? B, right? So I'm going to use B over sine of B. That's the form I'm going to use. And I'm just going to plug in what I know. I don't know A, so I'm going to leave it as A. But I know that sine of, I know A now is 49 degrees equals, I know that B, and if you needed to on your picture, you could have put B equals, is 27.4 over, and I know my angle measure, so sine of 28.7 degrees. Please make sure that your calculator is in what mode? Degrees. So go to your handy dandy calculator to check it, press mode right there, and my calculator is already set up in degrees. If your radians is lit up, you need to click down or scroll down over to degrees and you need to hit enter so that radians is no longer lit up, and then go second mode, second quit to get out of there. So now we're ready to try to solve. I need to see your algebra. We're going to cross multiply and solve. So cross multiply. So I'm going to bring my work up here because I'm fast going to run out of room. So I end up with A times the sine of 28.7 equals 27.4 times the sine of 49 degrees. Does anybody not know where I got those? We okay with that? Then to solve for A, don't I divide this side by sine of 28.7? Divide this whole side by sine of 28.7. So that all cancels, and A is approximately equal to, I would suggest, since they're out to tenths, that you go out to tenths. So I'm going to plug into my calculator exactly as I see that. So I'm going to use parentheses, by the way, for my numerator, just in case. I'm going to do parentheses 27.4 times the sine of 49. What's wrong? Do you need a calculator? Okay. And then don't forget that you have to end the sine parentheses, and then since I used parentheses originally, I have to put another set of parentheses up there. That's my whole numerator. I'm taking that entire numerator and dividing it by the sine of 28.7. And then hit enter. 43.1, because you're going to round up. So A is approximately 43.1. So that's my second missing piece of information. The third piece is going to be C, right? So if I were you, I would actually put in here A equals, bless you, 43.1. Now, what should I use in my proportion when I'm finding C? What would be the smartest thing to use in my proportion? Probably B. Why? Correct. Now, I did use A here, I didn't have a choice.
Yeah.
Right? Because I didn't choose that. But I definitely was given B, so I definitely always want to use the full side and angle that I was given. I definitely want to use that in each of my ratios, because I don't want to use A, because then if I made a mistake on A, I'll definitely get C wrong. Whereas perhaps I might still have a chance if I use B. Do you have a question?
Yeah, I didn't get that on my calculator.
Let me see your calculator. You either didn't use correct parentheses, or your mode wasn't right. You didn't use correct parentheses.
Well, I was re-entering just
Then divided by sine of 28.7. Now you got it. There's your parentheses. All right, so on this one, we're going to use B over sine of B equals, since I'm trying to find C, we're going to use C over sine of C. Now, if you want to be cantankerous and you want to do it the inverse, go right ahead. We'll still get the same answer. So I'm going to replace what I know. I know B is 27.4, and I know my sine of B. I know B is 28.7 equals, I don't know C, but I do know angle C. So I know it's sine of 102.3 degrees. So now cross multiply and solve. Remember, you can't cross cancel, but I can cross multiply. So I end up with C times the sine of 28.7 degrees equals 27.4 times the sine of 102.3 degrees. Then to solve for C, divide both sides by sine of 28.7 and sine of 28.7 degrees. So C is approximately equal to, so I'm going to plug that into my calculator. Parentheses 27.4 times sine of 102.3. Make sure, if you've done it my way, that you hit double parentheses. So there's my whole numerator, divided by sine of 28.7. Do I get what? 55.7. That's not so hard, is it? Here's where the issues plan to start to mess with you. So then we're going to look at situation 2. Question. It should be. So if you want to check, so Amber's pointing out the fact that if you look at your picture, which I highly suggest you draw, now that I know that C is 55.7, shouldn't the longest side be across from the largest angle? Is it? All right, and then my smallest angle is 28.7. Is it across from the smallest side? Very good check to use. Okay, so I can kind of tell you maybe if you perhaps made a mistake. It's not like we can just put that. Oh yeah.
But what does it matter if it's long?
Like, where's that?
Well, because let's say that you've got 10.7 for C.
Yeah.
That would make no sense because C is the largest angle out of the three, and remember your geometry. The
Yeah.
approximately largest angle is the largest side.
Yeah, but if you have to draw the scale, like it's just.
Well, no, you don't have to draw it to scale, but your numbers need to make sense. You're not necessarily going to draw it to scale. I won't necessarily draw it to scale. But you have to know which is your largest angle, which is your smallest angle, and that'll kind of tell you if you need to go back and rework things. Right, here's the hard part. It's a lot of stuff, right? All right, so number one, ambiguous case. The word ambiguous should make you a little nervous just to begin with, right? So you can split these 6 pictures into a set of 4 and a set of 2. When you have SSA, and only when you have SSA, this only occurs with a bad word spelled backwards, which is a bad deal altogether, so be careful. Right, boys?
Why is there ambiguity?
My boys.
Yeah, let's not, because they're over there talking. This isn't the same thing as the S and L skit either. All right, so consider a triangle which you're given A and B and angle A. Because wouldn't that be SSA, where I have an angle that is not in between the two sides that I've been given, right? It is not an included angle. Here are all the possible triangles that we could have. We could have a triangle where, look at this one, H is the altitude coming from the two sides that you have, going to the side that would be here if we were to create that missing side that we don't have. So this would be your altitude. If the length of this side is less than the altitude, is there any way for this to even make a triangle? At all? No. So one of the important facts is to know whether A, that length of the side across from angle A, the A that you've been given, is less than the altitude of that triangle. If you notice that right away, then your answer is there's no solution to this. It's not possible. All right, well, what if they're exactly the same? It's highly possible that this is a right triangle then, right? So if they're exactly the same, and this is an acute triangle, then you're only going to have one solution. If this is longer than this side here, then it is possible also to have one solution only. Well, what if your height here, this is your altitude, the height of your triangle. What if A is in between? Could be less than B or greater than the height. You could end up with two different triangles. You could have A being here, or you could have A being here. You could have two different triangles. Wouldn't that give you two different angle measures down here? That's the one that's kind of a pain that you might miss. So we're going to go through a couple of possibilities through this. Then the last one that I want to show you is, well, what if A is obtuse? Look at this picture. If the length of side A, which is across from the angle you're given, is less than this side B, it is not possible. Because remember, that's a fixed angle. It's not possible for this to make a triangle. So again, you're focused on A and B, and then your height. Whereas if A is greater than B, you will have one triangle that can be formed. I have also given you a way up here to find your height. Your height can be found by taking B, the length of side B, which is the side not across from the angle you've been given, and multiplying it to the sine of A. So not to confuse you, they're going to give you A's, B's, and angle A. They're not going to say, oh, I have C, C, and B. See what I'm trying to tell you? They're not going to mess up the letter names on you because this is hard enough as it is. So let's look at the first situation. Single solution case. They're all SSA, by the way. So here I'm given A is 22, B is 12, and your angle measure is 42. So I have an acute angle. So it's one of these four possibilities here. And then compare A to B. Because all I'm really concerned about is if A is greater than B or if A is less than B. Because if A, these two all deal with H. So is A greater than or less than B? Greater than B. So isn't that this right here? So very first thing I want you to note number one, is that angle A is acute, and A is greater than B, so it's one solution. So that's a good thing. Then we're going to attempt to try to draw it. Well, you could try to draw it. You could sketch it if you want to. It's up to you. Let's go ahead and sketch it. So if we were to try to sketch it, and we might sketch it wrong, but you know, it'll be okay. So if this is my A, and this would be B, and then this would be C. They have currently given me that A is 42 degrees, and that side A is 22, and side B across from angle B is 12. I have to find angle B, angle C, and side C. So it's not as easy as the last example where we just took 180 degrees and subtracted the sum of my angles, so I don't have that this time. So my very first step, I do have one of my ratios though, don't I? I have side A across from angle A, so can't I use 22 over the sine of 42 degrees? And then don't I have side B? So which angle do I want to try to find first, angle C or angle B? Because I've been given side B, I want to go for angle B, the one that I have the side for but I don't have the angle for. So find angle B. So we're going to do 22 over sine of 42 equals then side B 12 over sine of big B. Because I don't know my angle measure, it's going to involve the inverse sine, if you'll recall from geometry. I'm still going to cross multiply, so I'm still multiplying these two to these two. So now I end up with 22 times the sine of B is equal to 12 times the sine of 42. How do I get sine of B by itself? What are you going to do? Yep, divide both sides by 22, and I need to see the math. Don't worry about reducing because you're going to use your calculator. Now to find B, because I basically have sine of B here, whenever B, your angle is your variable, you're going to find big B is approximately equal to the inverse sine of all of this. 12 times sine of 42, all divided by 22. This is what you're putting in your inverse sine. It should look just like that in your calculator. So how do you get your inverse sine? Do you remember? Second, yeah. I'm trying to get out of the glare here. In case you're wondering what I'm doing. Let's see what I get. Alright, so inverse sine. Oh, you can't see a thing. Oh, it's not on. That would help. Inverse sine, there we go. Alright, so inverse sine of, and I'm going to use parentheses for my numerator. So parentheses 12 times sine of 42. That's ending my sine only. This is ending my numerator. And then divided by 22. And I need another parentheses to end what I'm taking the inverse sine of. Parentheses are huge. So then what'd you get? And they didn't say how far to go out to. And so just to be on the safe side, we're going to go to 2 decimal places. So 21.441. So B is approximately equal to 21.41 degrees. Now what would you like to go for next? The hardest part is always the first step. Now the rest of this is easy. What do you go for next? Angle C. Angle C would be smart because you have 2 angles now, right? So the next 2, the measure of angle C is equal to, you take 180 and subtract from that what we just found. So I know that I've got 42 degrees plus, oops, this is minus, 21.41 degrees. And I'm going to put my 21, 41 degrees here. And then so in your calculator, you're putting that, and you get what? 116.59. Approximately equal to 116.59 degrees. So the reason why I suggest you draw a picture so you can check your side lengths. So since this is the largest angle, shouldn't this end up being the largest side? And then this between these two is smaller, so this side should be smaller than this one, which it is. So far, so good. So last one, we're going to find the measure of side C. What ratio are you going to choose for sure? A, because you were given that information. So I'm going to take side A, which is 22, over the sine of 42 degrees, equals, I'm trying to find side C, over the sine of 116.59 degrees. Cross multiply and solve. C times sine of 42 equals 22, sine of 116.59, and then to solve, divide by sine of 42. So C is approximately equal to so 29.40. Does that make sense? Why? That would make this the biggest side, right? 29.40 out of all three, that would be the biggest side. So there are my three missing parts. So really, the only difficult part is trying to figure out what do I do for the first answer, or for the first step to get my answer. You all right with that? All right, so let's look at when there's a no solution. So a no solution case. You're given A is 15, B is 25, and angle A is 85. The only thing that you have to compare is A and B. What do you notice about A and B? A is less than B. So if A is less than B, that means that we're either here in this situation, or it could be this situation. What do I have to know? The height. So I've got to find the height of my triangle. So, very first thing I'm going to note is that A, angle A, is acute, because that brings me to one of those four. And on top of that, A is less than B. So I have to find my height. So step one, find height. So use that height formula above. So height is equal to B, which is 25, times the sine of A. And A is 85 degrees. So plug that in your calculator. You get 24.9. So A is approximately equal to 24.9. So now compare that to A. A is 15, H is 24.9. What are they to each other? So A is less than H. And according to this, it's no solution. So right there, without doing any work other than finding the height, can't you say no solution? So I want to show you something. I'm going to prove to you that it's no solution. Okay, you ready? You can choose to write this down or not. It's your choice. But I just want to explain. If I were to try to draw this, here's my 85 degrees. My side A would be across from here, it'd be 15, and then this is 25, so I made this visibly less than this one, right? There's no way, number one, that that line can move up to there at that point. Here's my height, which we just found was 24.9 units. So if I tried to use the law of sines, so because I've got A, I can do 15 over sine of 85, and I could try to find angle B by doing equals 25 over sine of B, which is what I did here. So if you forget and you don't realize that this is a no solution, you can attempt to find the solution, and just like the previous one, we would try to find B first because that's what we've been given. So if you go through all the solutions, cross multiply, divide by 15, look what you get for sine of B is going to equal 1.6603. That's not what B is, that's what sine of B would be. Wouldn't you do the inverse sine to get that? If you try to plug that in as an inverse sine, it's going to give you an error message. Why? It's the inverse sine of 1.6603. Why do I get an error message? What does it say? Domain, right? Remember the domain for sine and cosine is between -1 and 1, and since this is out of the range of 1, that's why it's going to give you an error message. So that should be a clue that, oh, I forgot, that's right. If I found h, a is less than h, that would have told me for sure. You could even go through this and tell me no solution because of this. I don't care which way you do it. This is just takes you longer, that's all. All right, so then flip it over. Last page, we'll look at one more situation. This time we have the two solutions. It's a bit of a pain because you have to do two separate problems. So the first thing that I note is A is acute, right? So number one, angle A is acute. And compare A and B. A is what to B? Less than B, right? So if you look at this, it's again either this situation or we have to find what? H. So just like the last one, the minute A is less than B, you have to find the height of the triangle. So we're going to go find the height. So that's number one. So I'm going to put here that A is less than B. So that's why I'm finding the height. And so my height is what? B sine of A. So B is 31 times sine of 20.5. And so the handy dandy calculator. And I get 10.86. We'll go out to 2 decimal places to be safe. So 10.86. So compare A to the height now. A is greater than, right? So A is greater than H. So go back to the sheet before this. If A is greater than H, read this backwards, and less than B, then don't we have two situations? Yay. So, I'm not going to draw a picture on this one, it gets a little complicated. So, what do you suggest that we find first?
Angle B.
Yeah, angle B, that hasn't changed. So, I'm still going to find angle B. So, step 2. I've got 12. Which is side A, over the sine of 20.5 equals, and then my B is 31 over sine of B. So cross multiply, I get 12 times sine of B is equal to 31 times sine of 20.5, and then divide by 12. And then you can figure out if you don't want to put all of this in the inverse sine, then just figure out the 4-digit decimal. So another way to do this, other than the way I did it before, was you can say the sine of B is approximately equal to, and then we're going to figure out and go out to 4 digits and you'll be okay. I'm gonna do 31 times the sine of 20.5, hit enter, and then I'm gonna divide that by 12. So can't I use 0.9047? Right? So I'm gonna use 0.9047. Then in your calculator to find b, you wanna do the inverse sine of 0.9047. Whoops. And so then here, inverse sine. What do I get? 64.8 degrees. But that's really only for b sub 1. Because remember, we have two different answers. So this is for angle b sub 1, because that's one possibility. Question. Yeah, by the way, I forgot to tell the three of you, you can take out your formula sheet. You can use it now. I meant to stop y'all a little earlier. Take out your goldenrod formula sheet, you can use those now. All right, so then, if that's b sub 1, let's go ahead and find b, or can I find c sub 1? My first set of answers for b and c. So measure of angle c sub 1 is equal to 180 minus, I'm going to add these together. So I was given a is 20.5 plus b is 64.8. What do you get? What do you get? Yeah, you get 94 point, did you get 7? Yeah. So this is C sub 1. So in the same vein, I want to go find side C. I just want to finish up the first set of solutions because then I have a second set. So side C, I'm still going to use the A ratio. So I'm going to use 12 over sine of 20.5 is equal to, but for C I want to use little c, over, now I know that one of my solutions for C could be 94.7 degrees. So cross multiply and solve. Won't C be equal to this? All divided by sine of 20.5. If you cross multiply and solve, and then throw that in your calculator. $34.2 or 34.15, it doesn't matter. So that's C sub 1. Let's make that C sub 1. Did you get it?
I got 34.
Watch your parentheses. So if I do,
You got 34.
did I get oh, oops, yeah, sorry, I did. Oh, I did, I just wrote it right down. You're right, it's 34.15. Just checking your eyes. Sorry. You thought you were crazy then, right? Okay. Then, can't I find, how am I going to find my other B? What would my other B be? Yeah, what would my other B be? Let's look at what B sub 2 should be, or could be. So go down to here. If that's B sub 1, then angle B sub 2 could equal. If I got 64.8, take 180 and subtract 64.8. What do you get? Do it on your calc. So 115.22. That could have been angle B sub 2.
Oh, it's just 42.
Oh, it's because I was using 0.78 before. So yeah. Yeah. So 2.2 or 0.2, whichever one. I put 7.8 in there. All right, so what if that's my B sub 2? So how did I get that? Again, I took originally this, which I got from my inverse sine, right? So I took 180 and subtracted that instead, and I could have gotten this one. Either one of those are going to work. Watch what happens. So look at step 4. So the measure of angle C sub 2 would be 180 degrees minus A, which is 20.5, plus my new B sub 2, 115.22. What does that give me? What'd you get? 44.3, or in your case, 44.28, right? 44.3. B sub 2, yeah, if you're using B sub 2 is 115, then C sub 2 would be 44.3. So angle B ends up being the larger angle this time, so wouldn't side B end up being the larger side? So if I know that side B is 31, then for side C I'm going to get something less than 31, right? All right, so let's go ahead and use our proportion. So we're going to put, I'm going to try to squeeze it in here. We're still using 12 over the sine of 20.5 is equal to C over, but my new C is sine of 44.3. So move it down there. Oh, you couldn't see that. Sorry, there it is. And so C is approximately equal to C sub 2. If I cross multiply, I've got 12 times sine of 44.3 divided by sine of 20.5. I'm running out of room, so I didn't use my algebra. Hopefully you got that. All right, so then go ahead and figure that one out. It should be less than 31. And did we get something less than 31? Yeah. So then C sub 2 is approximately equal to 23.9. So it is a bit of a pain when you're doing the ambiguous case, because you end up, finding a lot more than just 3 additional things. Then the last thing, and this is very quick, you'll like this one. The area of an oblique triangle, meaning a triangle without a right angle. Remember that the formula for the area of any triangle, just put it there, is 1/2 base times height. So this area formula right here, the way Mr. Gleason wrote this in here, it looks like it's all one formula, but it's really 3 in 1. Let's say that you're given B and C and sine of A. Notice that you don't have the side opposite the angle that they gave you. You want the 2 sides that are not opposite the angle that they gave you. And so it could be that, or it could be this, or it could be this. But notice that it's always, if you've got A times C, then it's sine of angle B. So it's really easy to memorize. So then let's look at this. I would draw kind of a picture of what's going on. Find the area of a triangle lot having 2 sides of lengths. So here's my 2 sides. 90 meters and 52. Doesn't matter which is which. And in included angles, so this is important, the included angle, doesn't that mean the 102 degrees will go there? It means it's in between those 2 sides. And that's what we're looking for, is two sides. We're looking for a SAS format. So it doesn't really matter to me which is A, B, or C. To find the area, aren't I going to take 1/2? I'm going to take my two side lengths that they give me, in this case 52 meters times 90 meters, and I'm going to multiply that to the sine of the included angle. And the sine is 102. And I'm going to put all of that in my calculator. You can use 0.5 for 1/2 if you prefer, which if I were you, I probably would do. What do we get? 2,288 point, they didn't tell us where to round, so go to two places. 87, and isn't this meters squared? And shouldn't area be meters squared anyway? Done.